You might have heard this question before. Are we living in a simulation? Is our world just a computer game being played by some other advanced civilization out there in the universe? You might think it's a crazy idea, but actually scientists are talking about it more and more these days. In 2022, a team of researchers from the University of Oxford published an academic paper arguing that we may be living in a computer simulation created by an advanced alien civilization. The idea that we could be living in a simulation has also been explored by scientists at the Massachusetts Institute of Technology and the Canadian Center for Addiction and Mental Health. Let's take a look at 3 pieces of space evidence they've been pointing to lately. In other words, we might be seeing all the galaxies in the universe, but they're closer than we think. Black holes are regions of space with gravity so intense that nothing, not even light, can escape their grasp. They're like cosmic drains where anything that ventures too close gets pulled in and disappears forever. A black hole's point of no return is called the event horizon, and its size determines its mass. Maybe the event horizon is just a wall that keeps our simulated reality from bleeding into other simulations. Well, in it, they talk about simulations running on computers and how if we assume that there are lots of civilizations out there in the universe. And so, just because we haven't discovered any evidence of them being simulated doesn't mean that we're not living in a simulation. And in the real world, sometimes people experience anxiety and depression. And if that's you, please know that there is help available. To prove that we're not living in a simulation, we would have to show that the laws of physics are unique to our universe and can't be replicated. And we'd have to do that in every single fundamental aspect of our reality. But the authors say we'd be looking for the needle in a haystack because there are many ways our universe could work and only one way that it actually does. So until we prove that every single one of those other ways doesn't work, we can't say with certainty that we're not living in a simulation. It's very likely that some of them would be technologically advanced enough to create realistic simulations. And if we're talking about realism, then it stands to reason that a simulated world would need to include the fundamental building blocks of our universe, things like space, time, and matter. But the authors of the letter point out that space, time, and matter could be simulated in different ways. For example, we know that the strength of gravity depends on the mass of the objects involved and the distance between them. But in a simulation, gravity could be generated in a completely different way. Maybe it's just a rule of the simulation that when character A gets close to character B, a force field draws them together. Or maybe it's handled by tiny little simulated robots underneath every planet pushing and pulling on it to make sure it stays in orbit. Imagine a video game where the world is divided into different levels or zones, each with its own set of rules and boundaries. Players can move freely within their own zone, but when they reach the edge of the zone, they encounter an invisible barrier that prevents them from entering other zones. This barrier acts like an event horizon, defining the limits of each level and preventing players from accessing areas outside their own zone. Similarly, in a simulation, black holes could be represented by invisible barriers that prevent simulated beings from entering certain areas of the simulation. These barriers could be placed at strategic points to control the movement of simulated beings and prevent them from accessing areas that are outside the scope of their simulation. In this way, black holes could serve as a way to segment different simulations and prevent them from interfering with each other. This idea could help explain why we haven't detected any signs of other simulations or universes. Each simulation could be isolated from the others, and the boundaries between them could be hidden from our view. Scientists measure a black hole's mass by observing its gravitational effects on nearby matter, such as stars or gas. Maybe the reason we haven't run into any aliens yet is because we're all in the same simulation, and they're all part of the code that hasn't been unrolled yet. Maybe we're still downloading. And in 2023, over 1,000 scientists and scholars signed an open letter saying that the simulation hypothesis is something that should be taken seriously. So how do scientists think we could be living in a space simulation? It can't send any signals or information back to the outside world. Some scientists believe that the key to solving this mystery lies in the bizarre nature of quantum mechanics. They propose that the information contained in objects near the event horizon is not truly lost, but rather encoded in a highly scrambled and complex way on the surface of the black hole. This surface is known as the firewall, and it's a thin boundary around the event horizon. According to this theory, when an object approaches a black hole, its information is transferred to the firewall in a highly compressed form. As the object crosses the event horizon, the information is scrambled and becomes extremely difficult to decipher. However, it remains on the firewall and can potentially be decoded if the necessary computational resources were available. This idea suggests that black holes could be information-rich objects, storing vast amounts of data on their surfaces. This challenges the prevailing view of black holes as cosmic vacuum cleaners that destroy all information. Instead, it proposes that black holes can act as information carriers, preserving and scrambling data from objects that fall into them. This means that anything that falls into a black hole is forever trapped and can never be retrieved. This poses a problem for scientists because it seems to conflict with another well-established scientific principle, conservation of information. This principle states that information cannot be destroyed and must be conserved in any physical process. Researchers say that if the universe had no beginning, then all the galaxies we see today would be infinitely old. But since we can observe a beginning with the cosmic microwave background, we know that our universe began with the Big Bang theory. Therefore, there must be a finite amount of light that's been traveling towards us since the Big Bang. This would mean that all the galaxies we see right now are all that exist, and everything we see is only a few dozen billion years old. However, when we use the Hubble constant, which is the rate at which the universe is expanding, and apply it to the distance of these galaxies, we find that their light would have taken longer than the age of the universe to reach us. So either the light isn't traveling all the way to Earth, or the universe is expanding faster than we realize. Number 1 is what we can see with the James Webb Space Telescope. If you've seen the incredible pictures that this telescope has taken so far, you know that it can basically see back through time. The James Webb Space Telescope can see so far back because light takes time to travel. So the farther away an object is, the farther back in time we're seeing it. Now, we don't know exactly how far back the Webb can see, but the furthest any telescope has ever seen was 13.4 billion years back. That would be the famous image of the galaxy, known as Glass, said to be the most distant galaxy ever found. Now, if we were living in a simulation, this fact that the universe is expanding and we can see so far back in time could be explained. If the universe is accelerating, it would explain why the farthest galaxies seem so much more distant than they should be. Number 2 is the information contained within a black hole. But here's the mind-bending part. According to Einstein's theory of general relativity, once something crosses the event horizon, it's gone for good. So how can information be destroyed inside a black hole without violating this principle? But if we are living in a simulation, maybe black holes aren't really black holes at all. Which leads us to number 3. Do you remember that open letter we mentioned earlier, the one signed by over 1,000 scientists and scholars? The author's point is that there are countless ways that these fundamental elements of our universe could be simulated. Now, whether or not we're living in a simulation, there's one thing we know we're living in, and that's the real world.